Hi and welcome to Prototype. We'll be solving the problem for LeetCode 733, Flood Fill. This is another problem in the LeetCode 75 study plan. Let's get to it. So an image is represented by an m by n integer grid image, where image ij represents the pixel value of the image. You are also given three integers sr, or starting row, sc for starting column, and color. You should perform a flood fill on the image starting from the pixel image srsc. To perform a flood fill, consider the starting pixel plus any pixels connected forward directionally, or adjacent, you could say, to the starting pixel of the same color as the starting pixel, plus any pixels connected forward directionally, again adjacent to those pixels, also with the same color, key term here, also with the same color, and so on. Replace the color of all the aforementioned pixels with color, and then return the modified image after performing the flood fill. We're given an example. It's a 3x3 grid with some ones and zeros in there. It gives us the starting pixel with the center pixel with the value 1. Okay, and then it wants us to check. It doesn't really matter which order. Let's say left. Check the left. Is it the same value? 1 and 1. It is. So we're going to change. We're going to first change the first value if it is not already the target value. So we change the starting pixel to 2. Then we check the left one. Is this the same value as the original value for the starting pixel? Yes, it is. So we'll change this one to 2. And then let's say we'll check up, and then we'll change this to 2. The right is a different value, so we do nothing. The bottom is a different value, so we do nothing. And then we repeat this with the adjacent pixels to the pixels that we've changed. Okay. The easiest way to solve this is with depth first search, and I think it's fairly intuitive. You could also use breadth first search for this, but I think depth first search works very well. And let's do the recursive implementation to start. Let's have a variable to keep track of the current color. So this is, you could say, the current color or the starting pixel's initial color, I guess, and that is going to be image sr and sc. There is one base case we have to check. If the current color is equal to the target color, then do nothing. We just return the image right away. And again, if the starting pixel, let's say, was 1 and our target value was 1, well, we don't have to do anything to the starting pixel because it's already the target pixel color, or the target color, I should say. And then any adjacent pixel that already has the value 1, the same value as the starting pixel, also doesn't have anything that needs to be done. So if the current color is already the target color, we can just return the image. Okay. Let's make one helper function for out of bounds. And this is just checking if the current column and row is still valid indices. So, and we can just return the Boolean expression right away. So if the row is less than 0, or the column is less than 0, or the row is less than the image dot length, or the column is less than the image, pick a row, any, we'll just say the starting row, its length, then we're done. So this will check if it's out of bounds. If any of these are true, and actually these should be greater than or equal to, okay, if any of these are true, then we are out of bounds, okay, and in our function that's actually going to do the recursive calls, let's say DFS, it will also take a row and column. If the current row and column is out of bounds, or if the current pixel's color, so its value, is not the same as the starting pixel's original color, then we will return as well. Otherwise, what are we doing? Well, we're changing the current pixel's color to the target color. So this can just be color. And then we would call DFS on the adjacent pixels, and we can start anywhere. Let's say row -1, so you can say the upper pixel. and then the bottom pixel with row +1, and then the, let's say, left pixel with column -1, and then the right pixel with column +1. We will call DFS on the starting row and the starting column, and then we return the image at the end. Okay, let's run it. Okay, submit. Okay, 98.4%, perfect. Now, let's just talk quickly about converting this into an iterative solution, and that is actually very easy. We can use a stack. In JavaScript, there is no stack object, so we can just replicate it with an array. Okay, and then we'll have a while loop that will depend on whether the stack is not empty, right? Okay, what are we storing in the stack? It'll be the exact same parameters that we're passing into our DFS call. So the row and the column, we pass in the initial starting row and the initial starting column. And then we can pop off the value in the stack. So it will become row column is a stack.pop. And then we can basically use more or less the same code inside our original DFS function. Again, if it is out of bounds, or if the image, if the current pixel is not equal to the current color, then we're not going to return, but we will continue, right? Move on to the next one. Otherwise, the current pixel will take the target color, and we will have stack.push, and then just wrap these new pixel coordinates, you could say, onto the stack. Sorry, just bear with me 1 second here. Almost done. Okay, and that should be it. And submit. Okay, 94%. So there you go. Fairly straightforward, I think, in terms of the implementation once you've kind of wrapped your head around it. And there we go. So recursive and iterative solution for LeetCode 733 flood fill. Subscribe to see more. We will be doing the rest of the LeetCode 75 study plan questions in short order. Thank you and see you next time.